Welcome to Mrs. Bibb's Algebra 2 class, first 9 weeks. If you'll please fill in your table of contents, complete your warm-up. The warm-up this week is actually on several different slides, so complete your warm-up and then check it, please. You'll need Student Journal 24, 26, and 28. You'll also need a sheet of notebook paper. For Student Journal 24, this is page 23 in your notebook. What I want you to do is think about how these values in a quadratic function affect the way the graph looks. So if you'll take a few moments, think about the numbers that you've seen in these places, jot down a few notes, and then come back and check. The first thing that I wrote down has to do with this value of A. This value of A tells you several different things about the appearance of the graph of this parabola. If A is positive, that parabola or quadratic function points up. If it's negative, it's a reflection across the x-axis, which means that it points down. If the absolute value of A, so you no longer look to see if it's positive or negative, just the absolute value of A is greater than 1, then the graph of that quadratic function is more narrow than the parent function. If the absolute value of A is between 0 and 1, or if it's a decimal or a fraction, that's what that means, then it's wider than the parent function. Finally, if the absolute value of A is equal to 1, then it is the same size as the parent function. Next, I'll analyze H and K. Next, I analyzed H. H represents the horizontal movement of the function away from the origin, away from 0, 0, away from the ordered pairs that I gave you on page 2, I believe, in your notebook. Those ordered pairs are where the parent function is located. So once you know what this transformation is, if it's a plus h, then you go left h units. If it's a minus h, you go right h units. Then you may translate or move those ordered pairs that I gave you in these directions. Same thing for k. K represents vertical movement of the function, away from the origin and away from the ordered pairs that I had given you. If you have a plus k, that means you go up k units. If you have a minus k, you go down k units. The next thing I'd like for you to do is to match the capital letters that have the graphs with the lowercase letters that contain the equations. If you will please use the information that we just wrote down to help you decide which graph goes with which equation. I matched the equations with the graphs. I'd like you to notice that I highlighted in pink these 3 equations and these 3 graphs. As you can see, the A value for all 3 of these equations is negative. That means that I have a reflection of the parent function across the x-axis. The parent function, remember, is at the origin. So when the parent function is at the origin, it's pointing up. Every graph that pointed down is a reflection across the x-axis, and therefore would only be the correct choices for A, C, and F. The next thing I did was look at the left and right movement and up and down movement. This is right 2. So I looked at the graph and chose this one because it's a reflection of the parent function across the x-axis, and the function moved only right 2, not up or down. For this one, it's left 2, down 2. Which one of these two is left 2 down 2? That would be choice A. And then, of course, for lowercase f, E is the only correct answer. But if you notice, this is left 2, up 2. And that is a reflection across the x-axis, obviously, and then left 2, up 2. Next, I did the vertical and horizontal movement for the ones highlighted in blue. This is right 2, up 2, and it's pointing up because your A value is positive. So right 2, up 2 was letter C, right 2, up 2. For letter D, this is right 2, down 2. Also, if you'll notice, this is a fraction. The A value is a fraction. And looking at letter F, this is wider than the parent function. It's also right 2, down 2. The last one is letter B. As I look at letter B, this says only right 2. And of course, that's right 2. Hopefully you can see that letter B is also more narrow. That A value tells me it's more narrow than the parent function. 24, question 3. It's asking you to write the equation of the quadratic function whose graph is shown. And I've given you some hints, and those could be the explanation for your reasoning. Put those transformations into the vertex form, y equals a times the quantity x minus h squared plus k. The transformation is the same size of the parent function, so a equals 1. That will help you with that. I took a few notes for this particular problem. From the origin, this graph went right 1. That's a horizontal movement, so I have to remember it's the opposite when I put it inside of here. And it went down 2. That's a vertical movement, so I will use -2 for k. I wrote down a couple little things. Here's the equation in vertex form. Given to me in hint form is a is 1. I know I'm going right 1 and down 2. So hopefully from that, you can write this equation. Y equals the quantity x minus 1 squared minus 2. This is vertex form. Vertex form gives you the vertex. In vertex form, the vertex is HK. So when I look at this problem, the vertex is 1, -2. Right 1, down 2. I'd like for you to use your textbook to write down these definitions. You'll find these words within section 2.1. You can either write down what the textbook says or read it and write it in your own words. That is perfectly fine. Student Journal 28. We're going to look at these 3 graphs. We're going to describe the transformation of the parent function, and then we're going to graph the parent function. For the first one, there's only one transformation from the parent function to the g of x function, and that transformation is just up 4. The next thing I'll do is graph, and I'll just graph in pencil and then translate it up 4 with a pen. I'm going to draw the parent function. It appears this graph is going by 2's, so 0, 0, 1, 1, -1, 1. Then I'm going to sketch that parent function the best that I can. Make sure you make it look like a U and not a V. Then I'm going to move those 3 ordered pairs up 4 units. Remember, I'm going by 2's, so when I go here, I'm going to go up 2, 4. I'm going to go up 1, 2, 3, 4. 1, 2, 3, 4. Then I'm going to draw that function. So parent function, this one is g of x, and this one is f of x. For question 2, I have 2 transformations. I have right 1, down 3. I'm going to draw the parent function in pencil. 0, 0, 1, 1, negative 1, 1. I'm going to sketch that. Then I'm going to move it right 1, down 3. Right 1, down 1, 2, 3. Right 1, down 1, 2, 3. Right 1, down 1, 2, 3. And then sketch that graph. The last one has 2 transformations. It is a reflection across the x-axis, and it is also a translation left 9. Okay, let me draw the parent function. It appears these are going by 3s. 3, 6, 9, 12. Yes. So I'm going to put 0, 0. It's an estimate because of the scale. So here's my parent function. And then the first thing I'm going to do is reflect that function across the x-axis. So this point stays here, this point reflects across the x, this reflects across the x. If I were to sketch it, I'd sketch it here. I don't want to sketch it because it's not my final answer. Now I'm going to take these 3 ordered pairs, left 9. So 3, 6, 9. 3, 6, 9. 3, 6, 9. And then I'm going to sketch that graph. And this would be the graph of this function. Number 7 is our next question. I'd like for you to pause the video and answer this question. It says, consider the function f of x equals negative 10 times the quantity x minus 5 squared plus 7. It says to describe the transformations. There are 1, 2, 3, 4 transformations. So you should have 4 answers. And then it wants you to identify the vertex. I want to reveal these transformations to you one by one. So the first transformation I have highlighted in orange. That negative sign tells me that this is the graph of the reflection of the parent function across the x-axis. The 10, the absolute, because a is negative 10, the absolute value of negative 10 is 10, and that tells me that I have a vertical stretch of 10. Vertical stretch of 10 means that the graph of this function is more narrow than the parent function. For the pink here, that is a transformation of moving the parent function right 5, and the green is up 7, and then the vertex, hopefully you get the vertex. The vertex always comes from your left and right movement first. That's your x, and then your up and down movement next, up or down movement next, and that's your y. And the vertex is 5, 7.